This topic is about the principles of heat transfer, dry and moist heat, electromagnetic radiation, mechanical action, enzymes, and changes to pH. When going over this information, we will be focusing on describing and demonstrating chemical and physical changes that occur during heat transfer, dry and moist heat methods, electromagnetic radiation, mechanical action, enzymes, and changes to pH. Principles of heat transfer. There are three methods of heat transfer: conduction, convection, and radiation. Conduction occurs when something cold touches something hot. The cold object gets warmer. Basically, molecules in the solids vibrate and bump into each other, and they create energy and heat. They touch something, and this transfers that energy and heat to the other object. It happens when two or more solids come into contact with direct heat with each other. It occurs in frying eggs, pancakes, and fried steak. Another principle of heat transfer is convection, and that occurs when molecules move around in gases, in air, or liquids. The warmer liquid or air rises, and the colder liquid or air moves down below or takes the place of where the warmer air was. So it occurs in a circular kind of motion. Examples of this in cooking are boiling water with pasta, roasting chicken in an oven, and even making soup on the stove. Radiation is our third method of heat transfer, and that is heat and light rays that are called electromagnetic waves. They penetrate food. The electromagnetic waves reach the food, they are absorbed by the food, and the food heats up. There's no contact between the heat source and the food. Grillers, microwaves, and toasters all use this method to heat food, and some examples of this in cookery are grilled sausages, microwaved food, marshmallows on campfire, and also. You'll also need to understand the physical and chemical changes that occur to food during preparation and cooking. Physical changes are anything that alters the state of a food or a liquid. They can cause changes in the sensory properties of appearance and texture. Physical changes are usually reversible. So in the picture you can see here we have frozen peas. They're frozen, they've gone hard, and they're cold. However, they can be defrosted and they can be frozen again, and the same with the melting ice cream. The boiling water is bubbling and it's very hot. The texture is hot, however, it can go cold. The sliced citrus fruit is still citrus fruit. There's been no real significant changes other than a change to the shape. Those are examples of physical changes. Chemical changes occur when there's a breakage and formation of new bonds. They're usually irreversible. They can impact the flavour, aroma, sound, nutritional value, and the chemical composition of food. So once a tomato's ripened, it can't go back to being unripe. That's a chemical change. Once an egg has set, it cannot be changed back to an unset egg. Therefore, that is a chemical change. Baking bread is a chemical change. Marinating meat, once it's denatured, it cannot be reversed again. So these are all examples of chemical changes. In an exam, you may get a question about moist heat. Moist heat uses water, liquid, or steam to transfer heat to food. Examples are boiling, simmering, stewing or casseroling, steaming, poaching, blanching, and microwaving. The physical changes that can occur when you're using moist heat are that vegetables can become a duller colour the longer they are cooked. If they're cooked for a very short period of time, they can actually become brighter. Vegetables develop a deeper flavour. The longer the time, they lose their flavour. Tough cuts of meat require longer cooking in moist heat methods, and this increases the tenderness and the flavour of the meat. Proteins set and become a solid colour. We know this is coagulation. Starches become softer, bigger, and more tender. They're the physical changes of gelatinization. Food can also lose its shape if it's cooked too long when in a moist heat, and fat melts and liquefies. In terms of our chemical changes, our proteins denature and coagulate. Our starch gelatinize. Pectin in the walls of the vegetables break down and they allow moisture in, so they can become soggy, which is our physical change. The more water present, the more water-soluble vitamins are lost. That's a chemical change. Dry heat involves the use of circulation of hot air or dry contact with an object to transfer heat. So there's really not much water involved, or moist air. Baking is an example, microwave, although it does need some moisture in food. Toasting, grilling, barbecuing, frying and shallow frying because the food turns out dry, and deep frying. So some physical changes occur when we use dry heat. The fat melts and liquefies again, and that can actually help to make food moist and soften. Food turns brown. Food becomes harder. The meats can only tenderize slightly with dry heat. They're more likely to tenderize with moist heat. Foods turn out dry. They can become very dry. The foods can turn brown, and we know this is because of the Maillard reaction, dextrinization and caramelization, which are chemical changes. Our physical change is also that the food can actually become sweeter, stickier and darker in colour, so that's the appearance is changing, and that we know is caramelization. So the chemical changes that can occur during dry heat are proteins can denature and coagulate. Starches and sugars can dextrinize in dextrinization. The Maillard reaction causes the sugar and proteins or the starch and proteins to turn brown. Dextrinization occurs in starches. They go brown. Caramelization occurs in food containing sugar. That also goes brown and a stickier and darker colour. And little nutrients are lost during dry heat. So there's lots of changes with the physical and chemical changes with dry heat. Electromagnetic radiation. When we talk about electromagnetic radiation, we're talking about microwave cooking. Microwaves cook food using waves of radiation, just the same way we listen to a radio or we have an X-ray. Electromagnetic radiation in microwave cooking penetrates foods. They're waves that penetrate the food. The water molecules inside the food vibrate and they begin to jump into each other. That causes energy, and that energy helps to heat up and cook the food. That's really quite simple. Physical changes are that the food doesn't actually brown. Unusual flavours and smells can happen when you microwave cooking, and that's because the volatile substances can't actually escape that environment, and so they become far more dense, and that causes an off or a unique smell. But you might find that when you open a microwave door. Sometimes you might get brown patches on food if only a little bit of water is available. The chemical changes that occur in microwave cooking is it tends to have a minimal amount of nutrient loss, and they think that's because of the cooking time. So the less cooking time that's needed, the less nutrients are lost. Denaturation, coagulation and gelatinization all occur during microwave cooking, but browning methods don't. So food doesn't experience caramelization, the Maillard reaction or dextrinization. Area separated this into proteins, carbohydrates and fats. So when we look at proteins, we're usually slicing, dicing, mincing and pounding meat. This can actually cause the chemical change to denature proteins, and the physical change is that it can change its shape, but it can also tenderize the protein. Another one for protein is the beating of eggs, and the chemical change for this is aeration, and the physical change is that it actually creates a lighter texture and a more increased volume. Carbohydrates can, like your flours and things, they can be mixed into a batter, or you could knead a dough, and these are forms of mechanical action that can be used with carbohydrates. The chemical change that occurs with this is the development of gluten. And this is in many flours. In particular, wheat flour would be our most common. So wheat flour contains two proteins called glutenin and gliadin, and when you wet these proteins and manipulate them or use mechanical action, the two proteins begin joining together. The more you manipulate or the more mechanical action is, the more the proteins join up. So that's the chemical change that happens. The physical change is that the gluten actually makes the dough stronger and more elastic. It adds structure and strength to a dough or a baked good. That's why we have to knead bread for so long, because we need a really good texture. What that does is it enables the bread to stretch on baking so that it can hold the air produced through the production of carbon dioxide in yeast cookery. So the gluten makes the dough stronger, it makes it more elastic, it adds strength and structure to baked goods. The more mechanical action that's applied, the more gluten that is actually developed. That's why in cakes you shouldn't stir them too much. And if you do, they might be a bit chewy when you eat them. Pasta needs to be kneaded so that it can stretch out. A pastry doesn't need to be kneaded very much because we don't want it to be tough. So these are the reasons we use mechanical action in different ways with batters and doughs and things. Fat is our next one that can be manipulated with mechanical action. We can whisk, electric beat, blender, or use a food processor to add oil to food. And we usually do that when we make mayonnaise. And the chemical change that occurs then is emulsification. So we drip the oil in at the same time of mixing very quickly, and this disperses the oil evenly throughout the liquid. Makes the mayonnaise, it makes it creamier, and it gives it a really velvety texture and a thicker consistency or increased viscosity. And that's what produces as the physical change that I'm about because of emulsification. Enzymes. Enzymes are proteins, usually, and they speed up reactions in our cells and the food that we eat. They're catalysts that speed up reactions. We know that they cause reactions in our digestive system. They also cause reactions in our food. In starch, when you wet starch or flour, an enzyme will actually begin converting starch into a sugar, and that's a chemical change. The physical change is that the flour becomes sweeter, and that's sometimes why you might taste a pancake dough and it may be just that little bit sweet, and that's because that enzyme has begun to convert the starch into sugar. Another food that happens in is papaya, pineapple, kiwi fruit, figs and ginger. They contain enzymes that denature protein. Okay, so they denature protein, and they break the food down and they make the meat more. They make food more tender. And an example of this in cookery is adding those ingredients, papaya, pineapple, kiwi fruit, figs and ginger, to a marinade, and that will actually help make meat tender because they break down protein bonds. Fruit, when you expose fruit and cells to oxygen, you'll actually create melanin, which causes an enzymatic browning. So all you really need to know for that one is that the enzymes in fruit can actually cause enzymatic browning. They'll cause ripening and they'll cause food spoilage. So the enzymatic browning, the physical changes, is that it turns fruit brown. It ripens, it develops a deeper colour, a softer texture and a more flavoursome and sweeter aroma, and it eventually rots. Another example of an enzyme in cookery is milk and cheese. When you add the enzyme renin to milk, it will actually coagulate the milk, so it makes the milk form a solid, and that's referred to as coagulation. So it makes the protein firm, and that's the physical change. Changes to pH is another area we need to discuss. Basically, pH is the term used to describe how acidic or alkaline something is. We use a scale to measure the pH level of a liquid or a food. It ranges from 1 to 14. pH of 7 is neutral. Anything lower is acidic. So a 3 is lower, that means it's acidic. Anything higher than a 7, 8, 9, 10, they're all alkaline. Acids are lower than 7. So they are lemon juice, vinegar, citrus juice, and baking powder. Baking powder is slightly acidic. Alkaline ingredients are bicarbonate of soda and egg white. So that means they have a pH greater than 7. So we can add acid to vegetables and that will react the chemical change that happens is that they react with anthocyanins and chlorophyll. You probably won't need to know that for the exam. If they do ask you about that, that information will be given to you. These things cause acid in vegetables causes a colour change. It generally makes vegetables a duller colour. Adding alkaline to vegetables also causes a chemical change. The chlorophyll in the green fruits and vegetables, when it's exposed to heat and alkaline conditions, it turns into chlorophyllin. Okay, so that's the chemical change. Again, they would give you that information. Physical change is that sometimes the vegetables become softer and more mushy. Sometimes they get a bluish green tinge. In a hot alkaline environment, green fruits and vegetables can actually turn bright green at first, but too much alkaline will actually cause a bitter taste. Another thing that can be added, pH that can be altered food, is acids. So acids can be added to protein. They can be added to meat, and in that case they would denature the protein or weaken the protein bonds. And the physical changes that would occur is that the meat would become more tender, and it would also become more juicy because the meat begins to hold more moisture. Acids can also be added to the protein of egg white, and what that will do is, again, that will denature or weaken those protein bonds. So that's the chemical change. It helps with aeration. And the physical change is that it increases in the volume of the beaten egg whites and the stability. It keeps them stable as well. Alkaline and acids can also be used together, and we use them together to help aerate foods. So that's the chemical change. When they're used together, it's to aerate food. When you combine an acid with an alkaline, as you would in Anzac biscuits when you've got bicarbonate of soda, which is your alkaline, and that's been added with your golden syrup, which is an acid. When you combine those two things together with heat, it produces a gas. And that gas makes our Anzac biscuits lighter or an increase in volume. So that's how alkaline and acids work together. I've also provided here for you some past exam questions, and I've listed the papers and the questions that directly relate to this key knowledge. So you can actually start revising some of those questions now. Look at your exam link that I've given you, look up the questions and also write your answers, and then look at what the study design responses were given. So the examples of the answers that were given by VCAR as well for each of those questions. I've included a weekly exam tip with this slide, and it's for students who are worried about running out of time to answer questions on the exam, or who simply write too much information. So there's some tips here about how to reduce the amount of writing that you're doing for your answers and making sure that you answer questions accurately. There's some reasons why you do it there that are really good to cover, and also some exam advice has been given here for you too.